We're dealing with trig
Wait,
functions.
is this on?
Oh yeah, turn the camera on, Noah.
Yeah, it's on.
Oh.
It's been recorded. So we're dealing with trig functions of any angle, and in this situation, what we're doing is we're prepping to create that unit circle over there. But just like any shortcut in math, you have to understand how it's created. And a big part of this is from last year's, no, 2 years ago? I think we touched on it last year in Algebra 2, the special triangles, the 45, 45, 90, and then the 30, 60, 90. So these ratios right here, these special right triangles, is what's used for the unit circle. So there's 4 quadrants, right? And it's always in a C shape. Everything is related to this one quadrant right here, so the reference angle helps you take this, right? So if I took this terminal and I put it in standard position here, my values would still be the same. Does that make sense? So then I don't have to work on all of these. I can just take the acute and put everything according to quadrant 1. So in this case, this is -4 and 3. So that means my x, so it is -4. And my y is positive 3. So that means this one right here would look like this. Does that make sense? 4, comma 3. Sorry, -4, comma 3. You with me?
Wait, what?
Because this is the point. So it goes -4.
Oh, okay. Sure.
And it goes up 3.
Sure.
It's just normal graph.
Okay.
Something right.
Right, yeah. So in this case right here, my reference angle is theta prime. That's my reference angle. It's an acute angle in that quadrant, right? And I just ignored these checkpoints. It makes sense, but to explain it is kind of weird, so I just want you to be with me. So on this one right here, the entire angle is this right here. This is theta, right? My reference angle would be from this checkpoint. There's 1 checkpoint, 2 checkpoint, 3 checkpoint. From this checkpoint onto here. This is my theta prime. Are we understanding how to locate it?
Kinda,
Yes?
yeah.
You can also do it this way and do -theta prime. But it's in the acute angle that gets you to the same terminal side.
The acute.
Right. The acute angle from the
You
triangle.
always start from.
You don't have to. I can go from here to here and make it in
The
between.
positive always starts from the first quadrant.
Yes, positive goes counterclockwise, and then negative goes clockwise.
Is there any way to keep track of how many quadrants you've gone through so that it tells you, like...
You'd have to draw it out. But you learned how to draw it out last section.
Yeah.
Yeah. So, once you find this point, this is my x, and this is my y. And now you have your 6 trig functions according to x and y, and your r, right? The reason why we apply any angle is because then we can use these special triangles to get this ratio. And when these special triangles are what kind of triangles?
Right triangle.
Right triangles, so then I can use the Pythagorean Theorem. Okay? So, we have that written down. So, for number 1, it tells us, this is pretty straightforward, it tells us what the terminal side is, your x and y. So that means our r is the square root of -4 squared plus 3 squared, which is the square root of 16 plus 9, which is the square root of 25, which is 5.
Okay.
Yes?
Yeah.
So the radius is 5. Tanner, can you turn off the lights? We just turn off.
Okay.
So once I find r equals 5, x equals -4, and y equals 3, then the 6 trig functions are easy. Sine theta equals 3 over, you can fill this in while we're doing it. Cos theta equals -4 over r. Tan theta equals, what is it? Y over x. so 3 over negative 4. And then, whatchamacallit? The opposite is just flipping. So cosecant theta is 5 over 3. Secant theta is negative 5 over 4. And cotangent theta equals negative 4 over 3. More than one circle, right? So what I'm going to do is I'm going to go ahead and just turn it into degrees, just so I can draw it. That means what goes on top and what goes on the bottom?
Degrees goes on top.
No.
180.
What?
Pi goes on, no, you're right, 180 over pi. You cancel out. I end up with, what's 180 divided by 4? 90? Nope.
No, it's
45. This is 45. 45 times 15 is 675.
Yeah.
So 675 degrees, right? It's not fully 2 circles yet, so I'm going to take away at least 1 circle, 360. What do I end up with? 315 degrees. So this angle should be in which quadrant?
The fourth one.
Fourth one, right? Because this is the 270 mark.
Halfway in between.
So then, is it halfway?
Yeah, it's negative 45.
Okay, perfect. So this is 315 degrees.
Okay, well that's cool.
Right? And either way, my reference angle is 45 degrees.
Wait, but why do you need to draw it first?
Just so I can visualize it. It just helps a little bit more because we're going to be applying these.
Okay.
So that means what did I do here? Right. So that means I'm going to move this to the 45 standard position. Right? Making this how many degrees?
45.
45 degrees, right? My right angle is here. So this would be what kind of triangle?
Right.
45, 45, 90. So these are the ratios I'm going to be using. Yes?
Wait, why do you have to move it?
Oh.
So then I can show you from a, because these ones I'm going to be dealing with negatives and stuff,
Okay,
but this one I can just do it.
yeah. If
I can
you
just
did
focus
it-
on the
If you
positive.
did it as negative, that would be wrong. Or it's just.
No, it'd be fine. It'll just be.
But why, like, are you giving us those 2 triangles? Is those like special triangles that we're going to get most often?
These are the 2 triangles that all these values are bound by. These ratios.
Well, okay.
Right? So I'm trying to show you the amount, first I'm trying to show you the amount of work it takes to find one exact value and why it would be beneficial to know the unit circle. And then second, I'm trying to and show you how they use the special triangles to make the unit circle. So we have 45, 45, 90. So that means this is x, this is x, and this is x root 2. Right? And this is my radius right here. Right? And so my radius, hold on, is 15 pi over 4. So pi over 4 is my, let's see, it's all sorts of confused. Why am I? Oh, right. Okay. So I have. I know I figured this out. Hold on. I did it in my house. 45, 45, 90. This is. I'm going to turn 45 degrees into radians. what would that be? I multiply it by
Pi.
360 pi. Nope.
It's one.
Yeah.
I thought it's pi over 180.
It's gonna yell at me, but
Just kidding. Degrees. Equals 45 pi over 180, which is pi over 4.
what?
Pi over 4.
That's your radius.
This is my degrees in radian. Now, here's the thing. Some of you guys might not have, you didn't have to necessarily do this. If you know how to find the radians on the circle according to that, you could have just subtracted a pi from this to get you this, yeah? Do we understand that?
No.
Because I took this and converted it into degrees,
Why?
right? So that I knew where to draw it.
Okay.
I converted it into degrees, and then I took away 360 to find how many rotations there are. Because 675 is more than one circle.
Right.
So I subtracted 360 to find where it's at.
Okay, because it went around.
Right. So I could have, because I put it in degrees and put it back into radians. You could have just subtracted 2 pi from this. You'd have to find a common denominator and so on and so forth, but you could have just done that
Oh, okay.
and skipped this step. My brain needs it in degrees first because I'm so accustomed to degrees.
What if it goes over like 720?
What?
What if it goes over 720? We
You know what?
subtract.
You subtract two
Then you keep,
circles.
yeah, you just keep
Oh, okay.
subtracting however many circles there are. So we're looking for secant.
Wait, what was the point of doing pi over 4? Where is that?
That's the 45 degrees. That's the reference angle that I used.
Okay, but what is?
No. Sorry, the exact value of. Oh my, sorry. That's probably why you guys did this stuff.
What'd you do?
I forgot. It wants you to find the exact value of that.
Oh, because you're just saying secant. And I'm like, okay, good job for
Just
secant.
kidding. Wait, what? Right.
So you could just flip it though.
No, why?
Oh, well, you need to find the regular,
You can't flip it because this
the regular
whole thing.
cosine.
This whole thing is one value. Secant is r over x. Yes? You with me? Okay. So r is the radius here equals x over root 2. And then, according to this 45, x is
4. Or no.
here. The x values, which is, well, they're the same, so this is x. So this cancels out, and then, sorry, secant, no, secant theta equals r over x. And so this equals x, so the x cancels out, and I end up with just what?
Root 2.
So if you, secant theta is root 2. So that means x is root 2.
So wait, with every single
Secant,
circle.
okay, so hold on. Secant theta is root 2, all right?
Yeah.
So that means cos theta would be 1 over root 2.
Yeah.
In order, a combination of this with that in order to create that of the unit circle. Yes? Okay. So, I need you to be able to master how to find the values on the unit circle so it's not just your go-to unit. It's in case I decide that maybe we'll take your unit circle away and you have to find one of those measurements. That's probably what's going to happen. Just FYI. Okay, so it's asking us to find the exact value of cos pi over 3. So we're just going to find pi over 3 on your unit circle. It's pi over 3 is this one right here, your 60. And then basically the x and y, it tells us from the other board that your x is, what does it say? It doesn't say on your other board. Oh, it says it on top of page 248. I didn't write this last box. So your trig functions on a unit circle sine t equals y, cos t equals x, and then tan t equals y over x. So basically, this is sine, no, this is cos comma what? Sine. So, we're asking to have us find, this is the easiest part of the section. All you have to do is locate it and write it down, right? Because they already found all your values here through that method. That was the hardest part. So now you just have to find it. I know that each of these, this is cos and this is sine. And if I want to find tan, I put the y over the x, and if I want to find any of the others, I just have to flip them. Yes? We understand? No, we don't understand. Where are you stuck, guys? Because you're just staring at me right now.
Wait, y is cos x? X is always cosine? Why?
Yes, for all of these. So when it's asking for pi over 3, cos, what's the value?
Is x.
The value is x, which is what?
I can't see.
Look at your book. Pi over 3, the value of x.
Half.
1/2. That's cos pi. Pi over 3. If I want to find sine pi over 3, what would that be? I mean, yeah, pi over 3, what would that equal?
Root 3 over 2?
Root 3 over 2. If I wanted to find tan pi over 3, what would that be?
Yeah, where's the... However that would mathematically come out.
Tell me how to find it.
The half over y over x.
So 1/2
2 over 2 over half.
divided by, no, y. So root 2 over 2 divided by
Okay, that didn't
1/2.
Let's go right now.
Isn't it
Okay.
root 3? Root 2 over 2 divided by 1/2. Oh, sorry, root 3 over 2. I'm looking at the wrong one. It's over 1/2, which is the same thing as divided by 1/2. And how do we divide fractions?
You flip it.
We flip and multiply, so times 2 over 1. These cancel out, leaving me with just root 3. So the tan of pi over 3 is root 3. Yes?
Okay.
Cosecant of pi over 3?
You flip it. It's 2 over 1.
2 over 1. The secant of pi over 3?
2 over 1. 2 over 1.
Oh, sorry. Oh, which is 2. Pi over 3?
2 over root 3. I think you missed that step.
Huh?
2 over root 3.
2 over root 3, which they can't have a root on the bottom, so I have to multiply top and bottom by.
Root 3.
Oh, that's annoying.
So this, the roots cancel out, I end up 2 root 3 over 3. And then cotangent pi over 3 is?
1 over root 3, and then root 3 over 3.
3 over root 3, so I end up with
Root 3.
root 3 over 3.
Okay.
Do you understand how it's now easier with the unit circle? You just have to locate it. Whereas before, I had to find at least one of these through the special triangles.
Is that the whole other?
We understand?
Yeah.
And in the unit circle should be in both degrees and radians. Yes? You don't understand? Where are you stuck? Put your computer away and pay attention. Where are you stuck?
Where are you finding the stuff for pi over 3?
What?
What page do you find the stuff for pi
Boys,
over 3?
you need to keep up. We've been on page 248. Open your
I've
books
been on
there.
248. I just don't see it.
Open book 248. Find pi over 3. 60 degrees on my unit circle.
60 degrees. Yeah, I see 60 degrees.
Do you see pi over 3?
Yes.
That's where we get all our information right here. Right? Then we use what we have here. On a trig function, the y is your sine,